Hello, everybody. My name is Chase Robinson.
Hi everyone, I'm Stuti Biyani.
Hi, I'm Cassidy Huftalen. So we decided to perform collaborative filtering on a set of user ratings of different music artists. So the set of data that we chose to work with is on the Yahoo Music user artist ratings data. And then why did we pick the topic of music? So the reason we chose music is because it's a topic that really interests all of us, and we know that personally we're always looking for new recommendations for music and new artists we might like. So when we found such a huge data set of different artists, we wanted to construct a recommendation engine. So we thought it would be really cool to try to find and see connections in the data that we might be able to see in ourselves as well. And then what is our goal? So our goal for analyzing the data set is to see if we can predict a new artist that a specific music listener would like that they've never heard before based on how they rate other artists that they have listened to. So now Chase is going to explain the methodology of our project.
Okay, so the first thing that we're going to start with is data preprocessing. So originally, our data set was split into two separate files. One file contained the user IDs and user ratings, while the other file contained artist IDs and artist names. In order to understand the data, we combined these two files into one. So the next step we had to do was to check for null values, and we saw that there were none. And then what we did was we randomly selected a subset of the data set to run on our model. And the subset that we obtained had 17 million ratings corresponding to the rows of our data set. So next we did exploratory data analysis. So in this first graph, we plotted the number of unique values corresponding to each variable. And then in the second graph, it's a histogram that plots the user ratings. So you can see that the ratings are on a scale from 0 to 100. Then you see that we have a outlier rating of 255, and the rating 255 corresponded to a user saying that they never wanted to listen to that artist again. So basically, what we did was we set that rating equal to 0 in order to simplify our model. So then we had to choose a method. So the method that we chose to use was singular value decomposition. So the reason why we chose SVD was because it performs matrix factorization on our data set to reveal hidden features. This method was appropriate for our data set because SVD will approximate unknown ratings of each user for each artist. Then after approximating unknown ratings, we would give each user their top 10 recommendations for new artists. So obviously when we ran the model, we had to choose a training and a test split. So what we did was we chose 80% of the data to be training data and 20% of the data to be test data because it gave us our best possible result. So now we'll pass over the presentation to Stuti to give us our results.
Okay, so after fitting our model on the training and testing data, we got a root mean squared error of 3.4. The accuracy of the model is not that good because we trained our model on only a subset of the data set. Like there were total 1 million rows and we trained it on just 15% of it. So we trained our model on just 17 million rows. Now we can see that we can see the screenshot of the predictions and the actual ratings for a user that a user had given to any artist. So more or less we can say that for any actual rating which was greater than 70, the model predicted around like 100 for that. And our ultimate goal was to give top n recommendation of artists to users. So in this first screenshot you can see that it's just like a subset wherein we can see for some users we have mentioned like the top 10 artists that the model recommends. And to conclude, even though the model is not that accurate, we get a good understanding of how we can use SVD to design recommendation engines. And given more data to train the model, we can definitely get more accurate recommendations. Thank you.
Thank you.